Hello friends, we're going to do this again because it always goes pretty smoothly. So something came up with my parents and I'm going to miss just 5th and 6th hour, so it's like your lucky day. But I'm going to teach this because it's still an eyeball activity. You're going to do an IXL, you're going to be brilliant, and I'm going to see you on Monday. So let's roll. We already did limits to some degree. But what we're going to look at today and add in is what's called one-sided limits, and that means that you're only looking from the left like we did, or from the right. So we already talked about the fact that the limit from the left has to equal the limit from the right in order to give you a limit at that value. So here's the notation that you're going to see. If it's a left-sided limit, it's going to say limit of the function as x approaches the number, and then afterwards it's going to have a little negative sign, meaning from the negative side or the left end of the number line. If you're doing a right end, which is just new notation for what we did yesterday, it's going to show the limit of the function as x approaches the number, and then it'll have a little positive sign to remind you that you're coming at that value from the right end where positive numbers live. So we have this crazy graph, and there's going to be all these questions to answer. So let's do it. So this is going to be, because of this negative here, this is coming from the left towards the number -3 as an x value, and it's asking me what y value it approaches. So the first thing I would do is I would go to my graph and I would go to -1, 2, 3 on the x, since that's what I'm approaching. If you go to the left of that rather than to the right, you would be over here on this piece of graph. And you're going towards that -3x, wondering what y value are you approaching? And you're approaching 0. Then this next door neighbor is asking kind of the same question. You're still approaching -3, but now because of this positive sign, you're approaching it from the right. So if I do that, I'm to the right of -3, so over here, and as I approach -3 and stay on the graph, I actually go up to this value, which looks to be at 6. Because remember, my answers for limits are always y values. So you can kind of see how these lay out. You're checking the left, now you're checking the right, and then this one is asking for the overall limit, which is what we did yesterday. But because our left was a 0 and our right limit is a 6, the left doesn't equal the right, and so in this case I would write that that limit does not exist. There is not a limit here where x is -3, because coming at it from the left, coming at it from the right, you go in two totally different directions. All right, let's try the next row. This next one is still asking you a question, and I drew so much on here now that I got to erase it to be able to see. What it's asking you in this question here is something you've done forever. It's saying, hey, what happens when you actually plug in a -3? Like, what's the real value? So it's saying if x is -3, what is the y? So at -1, 2, 3, this is open and this is open, but this is the actual value, and that's at -1, 2, 3, 4. So my answer for this would be -4. So that's not asking for a limit. It's not asking what it approaches. It's straight up asking you what the number, like the y value, is at -3. Okay, so here I'm going to be approaching the number 5. Let's use a new color because that's fun. So if I'm going to be approaching 5 and I look here, I've got this negative afterwards, so I'm going to be doing it from the left. Then I'm going to guess, yep, this one has me going towards 5 from the right. And so I'll see if they're equal or not to determine here if the limit as x approaches 5 actually exists. We're looking to see, is it coming from the left and right going to equal the same thing? So first of all, let's find 5, which is at 1, 2, 3, 4, 5. They have this weird dotted line. That's a vertical asymptote. So nothing's actually touching it. Stuff just gets really close to it. So this one right here, number 5, is asking me to go to the left. Well, clearly this is the left and right of that value. So being on the left, I'd be on this part of graph, and you can see that it goes up forever, and it keeps going. So we call up forever positive infinity. From the right, you'd be on this piece of graph over here, but you're going towards that x equals 5 area, which is right here, x equals 5. So you're actually heading this direction towards that, and this heads downward forever. And they drew it as a dotted line so you could see that it's a vertical asymptote, insinuating this goes forever. And that we would call negative infinity. Okay, well, since negative infinity was our left limit, and positive infinity was the left limit and negative infinity is the right, they certainly don't equal each other. And so then this limit does not exist. The general overall, because in order for the overall limit to exist, your left and right limits have to be the same. Now it's asking me in number 8, what's the actual value? Well, I can't see because I drew all over it, so let me get rid of it. Well, I actually don't see anything graphed because the graph is all in this really nasty color orange. And since there is not anything in this whole entire row or column, I guess you'd call it, where the x is 5, this would have to basically be no solution. There isn't an answer there. You can also write does not exist. What about here? Next thing we're going to be analyzing is as x approaches -1 from the left. So let's go up here. Let's identify where x is -1, and then this is going to be dividing our graph into the left and right. This particular one, number 9, is asking us to approach from the left. So I'll do that. And as I approach the value, it gets really close to this open circle, which is located at -2 on the y. How about in number 10, I'm going towards that same -1, but from the right because of the little plus sign after. So I go to the right of this -1, get on the graph, and head towards that -1 value. I'm heading towards the same open circle, which is still located at -2. And since my left and right limits were the same, then in number 11, as it's asking the overall limit without a plus or minus sign up here, then I can say, yeah, that's going to be -2 because the left one equaled the right one equaled -2. So that's the first place that has a limit because from the left and right, they're both going towards this value of -2. Alrighty. Then in the 12th question, not surprisingly, it's actually asking me what is the value when you have a -1 as the x, what is the y? So I go back to my -1 and I'm looking. I don't see a value up here, and I actually don't have a value anywhere down here because this is open. So again, this one doesn't have a solution. Even though the limit exists, because they were both approaching that value, neither one of them ever got there, and there also isn't one of these like random dots somewhere on that vertical space where x equals -1. So my answer to 12 is that doesn't exist. There isn't an actual graph value for that -1. All right, so here we're approaching the number 2 from the left. So let's do that. Time to change colors. Where is x equals 2? Well, you've known that since middle school, sometime maybe elementary. So this is where my x is 2, this would be the left, this would be the right, all of which you knew in elementary school. So the first thing we're supposed to do is hop on the graph to the left and approach that value. What we're approaching is this dot right here, which is a y value of 1. How about if we do the same thing in number 14, but from the right? So I go to my 2, I get on the graph from the right of it and head in towards that line where x is 2, and I'm going to the same dot, which is still located at 1. So since my left equaled my right, and they both equaled 1, then my overall limit to 2, because this was 2 from the left, 2 from the right, overall 2 is going to have that same value. Because when you look at the graph and you go to an x of 2, you actually have a y value of 1. Okay, so last row to kind of go through, f of 2 is asking me for the value. Well, then that's going to be 1, because that's the y value. It's saying when x is 2, what is the y? Ooh, look at this. This is very exciting. This is asking x to go to infinity. Use your big brain. For x to go towards infinity forever and ever and ever, it's actually just asking, like, what is the right end of the entire graph going towards? So let's go check it out. The right end of the entire graph is going to be this. And if you follow this forever, you can see that it's getting really close but never touching the 0. So it gets closer and closer and approaches 0. What about this? This is saying to approach negative infinity. Well, we've done this before. If the right end is positive infinity, then the left end is negative infinity. So if you hop on the graph anywhere and you head towards the left end, this is going down slowly but surely, but it continues to go down further and further and further, which means it would be approaching negative infinity, because that's how we describe down. If something's going up at the ends, we do positive infinity. We did this when we did end behavior, so it's something we've looked at before. So this obviously is trying to make a lot of points. It's trying to say sometimes the limit can exist, but there isn't an actual value. Sometimes the limit and the value are the same. So you just have to take your time to kind of see what it is that you are doing. And so you can stop and tackle the IXL, or you can keep watching if you could use some more help, and I'll go through this next one. It's going to be the same thing. So the IXL that you're going to do today is still under the calculus tab, because that's what we're practicing. And you're going to be looking at E2, which is one-sided limits. So you're going to be looking for when it says limit of the function as x approaches n, you're looking for the little negative to indicate left, or if that subscript says n and then there's a little positive off to the right, you're going to be looking at it from the right. So if you're stopping here, have a fantastic weekend, do fun things, put your phone down, go outside, go see Greece, support your friends, and I look forward to seeing you on Monday, guys. Bye-bye. If you want more help, let's do it. All right, round 2. It's going to be the same concept. So I can't see. I'm too old. So the first number we're going to be approaching is -6. -6. This is saying -6 from the left, -6 from the right. Then we're going to see this is overall. So it's asking, is the left-hand limit equal to the right-hand limit? If it is, then that's our answer. If it's not, it doesn't exist. And then the fourth one goes with it and says, what's the actual value when x is -6? What is that y value? So those first 4 all go together, and they all focus on what is happening here when x is -6. So from the left, we're going to do left first because that's what question 1 says. This is going to be to the left and right of -6. So I hop on the graph, head towards that -6 vertical line, and I end up down here. I'm approaching this value. As I scoot over here and check out what that value is, it's a -2. What if in question 2, I go to the right of that vertical line at -6? Now I'm on this graph. Head towards this value of -6, and the graph goes down towards that same open circle, so it has the same value. So both the left and the right approach -2, which makes the -2 our overall limit as x approaches this -6 line. But when you actually say, okay, when I plug in a -6, what's the actual value? It's not -2 because that's open. It's this. So if I'm graphing at -6 up 1, 2, 3, 4, that's the actual point that gets graphed, not this open circle. So my answer in number 4 is +4, because that's the y value associated with -6. All right, now we shift to a new number that we're observing, and we're going to be observing -4 from the left, -4 from the right. Then we're going to look at -4 overall. So asking, does the left equal the right? If so, that's our answer. And then what's the actual value of y if you put in -4 as the x? So these next ones all go together. So let's start. We got to locate -4 on our graph, and that's right here. Then let's do what it asks us to in number 5 and go to the left of it. So I'd hop on the graph anywhere here and head towards this dotted line that's occurring at x equals -4. And as I do that, I'm approaching this value. This value scoots over on the y-axis and ends up right between 2 and 4, so it must be at 3. If I do what number 6 tells me to do and go to the right of this line we created at -4, I'll be on this piece of graph. And as I approach that -4 line, I also approach this same y value, which is still going to be a 3. So I know where this is going. Wouldn't be a video without me choking. So in the next one, it's saying, okay, is there an overall limit here as you pass through a -4 for x? And the answer is yeah, it's 3. Because my left-hand limit was 3, my right-hand limit is 3, so my overall limit is 3. The last question in that set is asking, what's the actual y value that goes with an x value of -4? If you plug in -4, what do you get out? So you're at -4. The actual value for the graph is right here. And again, that is 3. So it's just showing you, like in the first set of 4, I had a left limit of -2, right limit of -2, overall limit of -2, but the actual value was something different because that weird dot. In 5, 6, 7, and 8, I'm looking at this spot right here, and from the left, from the right, and actual value were all 3. So 5, 6, 7, and 8 are all 3. They're just trying to make that point. Next thing we're going to look at, it appears, is -1 from the left. You already know how it's going to go. Then you're going to look at -1 from the right. Then you're going to look at -1 overall. So does the left and right equal one another? Do they equal one another? And then that will be my answer. And then what is the y value when you actually have an x value of -1? So it's the same series of questions, but now we are approaching the number -1. So let me clean this up. -1 is hard to see. Okay, got it. Since this is -2, the -1 is actually this vertical asymptote, meaning the stuff around it doesn't really touch it, just like when we did vertical asymptotes. So that doesn't mean you can't approach something. So in number 9, if I'm on the left of that vertical line located at x equals -1, then I'm going to be on this piece of graph. And as I approach that blue dotted line, this goes down forever. And we like to call down forever negative infinity. How about on the right side in number 10? Well, this would be the right side. So get on the graph, follow it towards that blue line at -1 for x. It also goes down forever. So this goes down forever. What is the limit overall? Since they both went down forever, the limit is negative infinity. That's pretty bad. Let's try that again. Better. But this is kind of tricky. When you plug in a -1, what actual value do you get? Well, it's an asymptote. And you can never ever actually touch an asymptote, so there won't be a value, and so this is not going to have an answer. Both of these red wiggly lines that I drew go down forever and get really close to that vertical line at -1, but they never actually touch it, so there's never actually a value at -1. Alrighty, so the next thing we're looking at, because it's kind of just the same thing over and over, is going towards -2 from the left, going towards -2 from the right, asking to see if the left and right limits are the same or not, and then finally, what is the actual value if you use x equals -2? So let's find out. First, let's go to -2. That's right here. Because we want an x value of -2. We want to figure out where the left and right of that is. So to the left, you'd be on this graph, and you'd be approaching this, which is at 4. So the left-hand limit approaches 4. How about from the right? Well, if you're to the right of this line at x equals -2, you're on this graph, and it goes towards, but you'll notice open circle, but it still goes towards this y value, which is 0. So note, in number 15, the left-hand limit, which was 4, does not equal the right-hand limit, which was 0. So that means that the limit at that spot does not exist. If you look at it, you can see that this part goes up here, the right part goes down here. There's all this space in between where they don't converge together. So then it's asking in 16, what's the actual value at -2? Well, let's get rid of all of my markings. Okie doke. So if you're actually at -2, this is not the answer because it's an open circle. This is the value. So when x is -2, your y is actually 4. So that's what this is asking. What is this asking? As x goes to positive infinity, well, x will go to positive infinity over here. We've talked about right end and left end behavior before. So this is asking you about the right end of the entire graph. What is the right end doing? Well, the right end is right here, and it's approaching this dotted blue line that we call a horizontal asymptote, and that is located here at 1. So this orange right end of our graph is going to get closer and closer and closer to 1, but never really touch it because it is an asymptote. Last question is saying, hey, what about as x goes to negative infinity? Well, if you're on the x-axis and you're heading off to negative infinity, you are going this way. So it's saying, what does the farthest left end of your graph do? And we're on this part of the graph going off this direction, and they're saying if you continued, where would that go? Well, that end is going up. And in math, we call up positive infinity. And so that would be my last answer. So all throughout here, we're just trying to see what things get close to, unless it's a question like this, where it straight up says, what's the function's value at -6? Here, what's the function's actual value when x is -4? Here, what's the actual value when you go to -1 as an x? So everything else that says limit, 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 limit is asking what it's going towards. And then when it straight up says f of -1, f of -4, f of -6, it's giving you a specific number to look at and tell them the specific y that goes with it. Hopefully this makes sense. And again, a reminder, you are looking at the IXL in the Calc tab because we are that smart, and you're rolling on E2. So you have E1 from yesterday, E2 for Fun on a Friday, and then I will see you on Monday. Peace out, sisters and brothers.